Hello friends, today we are going to discuss about the Java language and its fundamentals. Before that we will just have a small recap of the first session. In the first session what we had discussed was basically how to execute a simple Java program which gives us the output called as hello world. That is what we discussed. In that we had two steps, one is compiling and one is running the program. For compiling we use the command called as javac. For running the program we use the command called as Java itself. Both these commands or the executables were available in the bin folder of the JDK. What happened was, when I compiled the Java program with the help of the file name, the output was the .last file. The content of the .last file was the bytecode. This bytecode was being loaded into the JVM with the help of one more command called as Java. Once the .last file has been was loaded, what happened was, it was looking out for the main method. If it finds the main method, the content of the main method was been executed. That's how we got the output called as hello world. Now we'll start understanding slowly the other fundamental parts of Java. That was just the basic program to just to give you an hint, just to give you an idea how the Java program actually works. Java is also a programming language which gives you the platform for J2EE, J2ME, J2SE. These are all some kind of versions, but these are all some technologies which Java language gives you the platform to develop multiple different technologies. Like every other programming language, even Java has something called as data types, right? Java has something called as data types, and this data types is divided in Java is divided into two things. One is primitive, one is user defined data types. In primitive, it is also categorized into eight primitive data types: int, float, double, long, boolean, char, byte and short. These are the 8 primitive data types what Java has given us. Coming back to user defined data types, Java has given us 3 user defined data types, that is called as class, abstract class, and then interface. When I speak about data types in Java, what happens is, every data type ultimately becomes a memory location irrespective of the value. Now I go ahead and say int, I'll go ahead and say int a is equal to 10. What happens? 10 is just a value. A can hold a value of 10 or 20 or 30, whatever it is, but this a is just a variable of type int, but this int will be in the JVM. For this int in data type, there is some memory which is going to be allocated, and that memory would be something similar to 4 bytes. Okay, but there are we can discuss about the primitive data types memory allocations later on, but the main point what I am trying to bring out here is, ultimately the data types becomes a memory allocation. So irrespective of any programming language, when I declare some int a, byte b, or whatever it is, it becomes a memory allocation. In the same way, a user defined data type also becomes a memory allocation. Okay, so there are 3 user defined data types: class, abstract class and interface, and for all these things Java allocates 8 bytes of memory. Okay. Now we also know Java is an object oriented programming language, right? Object oriented programming language. Now we need to understand what is an object. Object is an instance of a class, that everybody is aware of this particular statement. But what do you mean by instance? Instance means example. Object is an example of the class. To understand what is an object, we need to get into the programming language. We need to try to understand from a program. What we'll do is we'll try to understand an object with the help of a user defined data type called as class itself. We'll start understanding the behavior of the class, what all it contains, how we can work with the class. We'll start designing our own user defined data type. Why I am saying we are going to design is because when I say int a is equal to 10 or x value, what happens? JVM is in a state to understand what is int and what needs to be done, what kind of memory has to be allocated. But when I start designing my own user defined data type, I need to have some rules so that JVM can understand whatever I have designed. Basically, it's pretty simple. When I say user defined data type, it's a combination of primitive data types put together in a well formed manner or organized in a structured way becomes a user defined data type. That's it. Okay. Now we'll start understanding about the user defined data type. Now when I speak about class, what will this class consist of? Class consists of basically three things. The basic three things, building blocks of a class or a user defined data type is variables, methods, and then constructor. In this session, we are going to discuss more about the variables. In later sessions, we will be discussing about methods, constructors, and the other members what the class can have. But the basic members what the class can have is these three things: variables, methods, and constructors. These variables here will be basically called as instance variables, but slowly we will proceed. While proceeding, we will be discussing about all those things. So we'll start understanding the behavior of all these members of the class with the help of an example. We'll start designing a user defined data type called as class itself. Okay. Like in the last class we saw, class will be having some name. We'll name this class as box. This class has some variable int w, h, and int d. There is a class called as box which has w, h, and d. This is a perfect class, whether it has methods or constructors or variables, but this is a perfect class. It has three variables. These variables are called as instance variables. We will come back to that point why it is named as instance variables. But these variables are inside the class called as box, and these are the members of the class. Okay. Although this is a perfect class, I will not be able to work with this class because the reason is there is no main method available in this class. I can compile the program, the dot class file will be loaded into the JVM. The dot class file will be basically generated when I compile the program. But I will not be able to load this into the JVM. It does not have main method. The JVM what we saw was basically looking out for the main method. There are different kinds of JVM which is looking out for different kinds of methods that we can also discuss later in the later stages. Okay, because the main method available in the the JVM which is available in the server will be looking out for init, service, and destroy. The JVM which is available as part of JDK is looking out for the main method. There is a different JVM which is available for an applet which is looking out for different API. But what we need to understand here is the main method. In this particular program there is no main method. The JVM which we are using is looking out for the main method. If the main method is not available, it is not going to execute this particular program. So what should I do basically is I need to go and create, I need to go ahead and write one more class which will be having the main method. So let us write a class called as demo. Okay, this class will be having the main method public static void main string args. Okay, now let me try to create an object. So basically what I need to do is I need to bring this class box, I need to bring this class box whatever we have designed into existence. Right now it's not existing, it's somewhere out there, it's somewhere in the outer world, it's not inside the memory. So I need to bring this part of the code into existence. So what I need to do, I need to create an object of this. How would I create an object of this in Java? Pretty easy. Go ahead and say box B. What is this? It's just a variable declaration in Java. Many people misunderstand box B is an object. In Java it's just a variable. Like how? Int A. When I say this, what happens? A is just a variable of type int. In the same way, int is a primitive data type. A is just a variable of type int and int is a primitive data type. The same way, B is a variable of type box and box is a user defined data type. Okay, right now B is just a B is just a variable. Now when the variable starts pointing to the memory location, then it becomes an object. Oh, till now I have not allocated any memory for this class called as box. When I say new box, that is when the memory gets allocated. Now break this equal sign into two parts. Always analyze the right hand side of the equation. New box, what happens when I say new inside the JVM? There is one memory which gets allocated inside the JVM for the class called as box. This memory would be having some address. Let me take the address as 150 and which is referred by right now the B variable. The content of this is WH and D. The values would be somewhere around right now the values would be 0 because it's the default values would be assigned. I have not assigned any values in my box class here. I have not assigned any values here basically. So now it will be having the default values. Now when I say B is equal to new box, what has happened is one memory has been allocated and that memory address has been assigned to the variable called as B. Now B becomes an object. Through B I can access any members of the class. So what will I do is B is equal B dot W is equal to 10. I will be going to specify B dot H. Look at the program right now. What is happening is I am able to access the members. WH and D is not in this scope, but it is available in the class called as box. I am accessing it by creating an object using the dot operator. So right now the values of WH and D would have been updated to 10, 20 and 30. Okay, now if you try to print out system.out.println of B dot W SOP of B dot H and SOP of B dot D, what happens is basically the respective values called as 10, 20 and 30 would have been printed. If needed, I can also go ahead and create one more object the same way. I will just continue here, I don't have space there, so let's go ahead and say box B1 is equal to new box. What happens here is one more memory has been allocated in the JVM. One more memory has been allocated for the class called as box. The content of this would be same because I am creating the object from the same template. The values or initial values will also be same until unless you go ahead and update. Now I am going to say B1.W is equal to 1, B1.H is equal to 2, B1.D is equal to 3. What happens? The values gets updated to 1, 2 and 3 respectively inside this object. But the main thing here in this program, what you need to understand here is there are two different memory locations which has been allocated for the same class, but both the memories are isolated from each other and the values are also different. So here what I can say is these two objects are instance of this class, correct, right? These two objects or the memory locations are an example of this class. Basically what you need to understand here is object creation is nothing but bringing the code into existence. Existence in software means it's nothing but bringing the code into memory becomes a creation of an object. Once the memory has been created, that memory address would be handed over to the variable. So that variable, when it starts pointing to the memory location, it becomes an object. So this is basically how the object is being created and how we try to access the variables. That's why these variables are called as instance variables. In the next section, I will be uploading the video for execution of this program through Eclipse. If you have any questions, just post it down in the link, and if you like this video, just have a thumbs up. Thank you from Open Lambda. Thanks a lot.